because I made this test on roll film, on one roll of film, I was able to make 10 tests. So this exposure that I used, which was 125th of a second at f12.5, I shot the whole roll like that. And that was just rated to place this in zone 5. So you just use your meter, you set the ASA. Tri-X is, I rated at 320. I ran this test many years ago and I came up with 320 instead of 400. Tri-X is recommended to be shot at 400. The difference is a third of a stop when I rated at 320. And I came in with a microfiche. I like that developer. I diluted a 1 to 2 and I discarded after I use it. So it's a one-shot developer. That way it's very consistent when I use it. But I shoot all, the whole roll like that, and then I process each individual shot differently. Many years ago, in the early 60s, my father studied with Win Bullock. He also studied with Ansel Adams. He took a class with Ansel Adams as well, but he didn't understand Ansel's zone system very well. He told me that he really gravitated toward Win Bullock's, especially the way that Win Bullock saw and what he felt about photographs. And Win Bullock taught my father to use a green light. So with a green light, with a dark green light, after you develop your film for 50% of the time, you can turn on the green light. You can pull your film out, flip it over so you look at the emulsion side for just a couple of seconds, and you can see the image. And at that point, you can decide whether or not to process longer or shorter. And when Bullock taught my father to look for zone 5 when he was processing, and you compare zone 5 with the base of the film, that undeveloped part of the border of the film, and that contrast that you're looking for would determine when your processing was complete. My father did that for many years after he studied with Win, and he taught me that. And that's how I learned to process, by inspection. I don't do that anymore because it's not very scientific, and your memory of what zone 5 density should look like. I mean, if you're processing every day, I guess you could do that, but but I still use the green light to help me go through processing. So when processing is complete, I turn on the green light, and then I look at the film, and I put it into the stop bath. And I'll also mention at this point an old friend of mine, Nubar Demirtian. Nubar is from Armenia, and I worked with him at my father's lab for many years. And Nubar was the one who taught me to process 120 film evenly. I mean, you could process with a reel, and you turn the thing over, you do all these numbers, but when you photograph something like the sky that is perfectly even, maybe a few clouds here and there, I always had trouble trying to get the edge of the film to process evenly. I was talking to Nubar about this. So he says, "Oh, I'll show you what I learned in Armenia, in Lebanon, when he was working at a lab called Oscars." His boss had a lab named Oscars. And so Nubar showed me how he uses a tray, and he rolls the film from one end to the other, he turns around. So he does it all in total darkness. And when I tried it, lo and behold, I had very even skies. So that's how I process my roll film now, the way to do. And again, it's one shot, 1 to 2. And so I don't shoot a lot, but when I do process, I process one roll at a time. when I process 4x5 film, I do one sheet at a time. I don't try to process, you know, it's too hard to get even development otherwise. And the best test is just shoot a picture of the sky and process it, print it, and see if it's even. If it's not even, you need to take care of that. So when I shot a whole roll of 120 film of this image, I would process, let's see, my daily, I had 10 sheets, but this curve here was processed for, well, this is 8.5 minutes. This one, I think it was 5 minutes. I go up to 15 minutes, I think. I only labeled the normal. This is my normal, okay? But after a certain amount of time, I would take a scissor, I cut off that frame. I could see it because of the green light. I could see exactly where the frame ended, and I stop it, put it in a stop bath. And then after a certain amount of time, I cut another sheet, and I had to snip the edge of this film so that I knew which one was the first sheet and which one was the 10th sheet. Well, the two ends are easy because you have the leader to indicate. And you can obviously see that the longer processing got darker too. So that tells you also which one was first, second, third, fourth, all the way to the 10th or 8th, 8 exposures. When I'm shooting 2 1/4 by 3 inches, I only get 8 exposures per roll of film instead of 10. So then when I measure all these different areas, I can see that I'm getting a much darker reading on the one that was processed for 17 minutes, right? And the one that was processed only for 4 minutes, of course, it's going to be much thinner. So that tells me how the curve that I'm will move in one roll of film. I get all this data with one roll of film. The main difference between doing this as opposed to shooting one sheet of 4x5 film just to ascertain zone 1 and one sheet of film to ascertain what is zone 2, and you might go through 20 sheets to find out, to get one set of data, and then you have to do a whole nother set to find out what 15 minutes would do, or 8 minutes versus 20 minutes. You could spend a whole week doing this, which is a really good exercise, but a lot of people won't do it. But this is done in one shot, and the main difference is you incorporate the flare that you would inherently get when you're shooting with film. You see, in order to get zone 1, you might be using f/22 at 250th of a second. Very little flare, very little exposure. But when your normal exposure is 1/25th a second f/11, that's a lot more exposure. And zone 1 is going to get a lot more exposure because of all the light that's bouncing around inside the camera and overexposing zone 1. So not only do you get the exposure that creates zone 2, zone 1, but you get the flare, which is non-image exposing light. So these curves incorporate flare. You actually see the amount of flare. So you're going to get a much higher recording on the bottom of your curve, which is reality. This is what you're really going to deal with when you're shooting with a camera with film. Okay, now, which one of these sheets of film that I processed designates normal? Well, what designates normal is when zone 3 to zone 7 gives you a density range of 0.75. Going back to session 1, that's where detail can be easily rendered when you're making a print. Okay. Now, I've got data here. Hopefully you can see. Okay, I decided to put a slide up of this combined data and refer to it so that you can look at it closely. Notice that on the bottom of the graph, in Roman numerals, I have 1 to 10, and they are evenly spaced apart. Those are the 10 zones, if you will. And on the left of the graph are measurements going from 0 to 2.8. And those are the densitometer measurements taken off of the film that I recorded. Now, there are rectangular gray boxes on the bottom which indicate the scene itself. So, for example, there's nothing on zone 8, but beyond 8 1/3, I do have a rectangular box. That's because in my scene, I had an object in the backyard that reflected 8 1/3 of a stop. We have data that falls right on 5, 5 1/3, 5 2/3, and then on 6 and 6 1/3. So you have a bunch of 5 rectangulars there. So again, a meter that will give you a readout. If you just place that, whatever you read, into the middle of that meter, that if you just record it on the meter, it'll give you the exposure required to place that metered area into zone 5, which is a middle gray, if you will. So the meter doesn't think for you. It just says, okay, this much light is being reflected back, given this exposure with this type of film, this speed. In this case, I rated it Tri-X at 320 ISO. Then that area will be recorded onto the film, and after you process it, it'll render a middle gray. Anything that reflected more light than that would approach white. Anything that reflected less light than that would be darker than gray and approach black. So when I photographed the scene and decided to place the corner of that cardboard that received shadow in zone 5, all the other recordings fell accordingly. So for example, the white cardboard on the very left recorded was placed in zone 9 1/3. So when I read the negative in that area, whatever densitometer reading it gave me, I would plot along that line, if you will, going above 9 1/3. I would plot that density. So the plots that I'm showing you are 4 exposures. Now, I believe I shot 10, but I only chose 4 to plot because some of them was really close to one another. And it turns out that the bottom curve received 5 minutes of development, and the second curve, 8.5 minutes of development. Then the one above that was 12 minutes, and the maximum I gave was 15 minutes, and it wasn't enough. I should have given at least 20 minutes, it turns out. But this was the data that I received from this one test. And if we refer to the 8.5 minutes, if you look at zone 7 and you go straight up to where it intersects, the curve intersects with that horizontal line, you get a reading of about 1.1
1.17. And if you look at zone 3, following down along that curve, that measurement on a negative, I measured about 0.50. And so 1.17 minus 0.50 gave me a density range of 0.67. Now my aim was 0.75. So that tells me that 8.5 minutes isn't quite normal. So I decided to use my normal at development of 9 minutes. So at the top of this graph, you'll see normal equals 9 minutes. And this is for Tri-X 120 film in microfilm developer diluted 1 to 2 at 70 degrees. And that's how I came up with 9 minutes as my normal. Now, when people used to come, when I had my lab, and people would come and say, "Oh, push this one stop," we would process longer, and 1 or 2 stops we process even a longer period of time. The way that we came up with how much longer is not the way that the zone system specifies how to push film. Because when you push film, what you're doing is you're increasing the contrast of the curve. And so if you look at the 12 minutes, which is what I've indicated there is I've indicated zone 6 and instead of zone 7. So in a zone system, when you push one stop, what you're trying to do is you're trying to achieve a density range of 0.75, not between zone 7 and 3, but between 6 and 3. So in this case, at the 12-minute development, I got a reading on zone 6 of 1.34. Zone 3 in this case measured 0.72. So that density range was only 0.62. And that is close to one stop. So again, pushing one stop means getting a greater density range between zone 6 and 3, not 7 and 3. And likewise, zone 5, if you were to push zone 5 to achieve a density range between zone 5 and zone 3 of 0.75, which is really extreme, it would be considered normal plus 2 stops. But getting back to 12 minutes, 0.62 isn't enough for normal plus 1. So on the top of this page, I put normal plus 1 as 14 minutes. And the aim is 0.75. Now, when would you use this? Well, a good example would be like a snow scene where you didn't want to render the detail in the snow. You just wanted the snow to be quite a bit whiter than what was in front of you when you're photographing a snow scene. And if you just wanted a hint of white, you could increase the snow to be lifted up to just give you a density on the paper without detail. And at the same time, the trees then that coming out of snow would be farther away from that white snow and would render the trees darker. So if you saw this and this is what you wanted, you could photograph in this way and process accordingly and get a negative that would approach what it is you wanted to achieve in your photograph. And this is different than rendering accurately what was in front of the camera. So depending on the lighting of any given day, if the snow fell on zone 7 and a tree detail fell on zone 3, and that's not what you wanted, you could go ahead and expose the film as such, but give it normal +1 process, and then the snow detail would be pushed up the curve, and you'll get more. Now you can do this with just switching papers, going to a higher contrast paper, but, and this is really important, the value in the zone system is not simply that it helps you with exposure. You capture the detail from between 3 and 7, and you look at a scene and say, I want detail here and I want detail there, and you expose and process accordingly. You can do that. But the real value in learning this is taking something that's in front of you and seeing something else and then making it happen. So if you come across a scene that's really like a drabby day where it's really overcast and there's not much going on, but you like the design, you like the geometry, the architecture, how the lines flow, and you're seeing something that is there but not brought out by the given lighting of the day, you can go ahead and expose accordingly, process accordingly, and then when you print this picture, you can bring out what you saw or felt when you were photographing. A good example is a drabby day where it's overcast and the sun's coming through the mist or the fog, but it's not real clear. And if you were to capture just that, then maybe the rest of the scene would be really dark. So this is a case where you go ahead and you capture all the information on the film, process as best you can to render, and then with the use of masking, you can just add a supplementary mask and bring out what it is that is in the film, but the paper response doesn't quite fit. And so in a case like that, this particular shot, I was able to use masking to bring out the detail and the contrast that I wanted.